In this section, we are going to cover dynamic programming. We will go over some classical problems as well as a couple more advanced ones. We will also discuss some common optimizations, their proper implementations, and the advantages and disadvantages of such optimizations regarding dynamic programming. In this video, we are going to talk about what DP is and isn't. So dynamic programming is a problem-solving paradigm that solves problems by breaking them down into smaller sub-problems. But so does recursion and divide and conquer. So what is the difference between these three? In order to classify a problem as a dynamic programming problem, it must have two things at the same time. First of all, it must have optimal substructure. That means that solutions to sub-problems must contribute to the original problem. This is also the case for most recursion and divide and conquer algorithms. However, the thing that differentiates DP from the other paradigms is that it must have overlapping sub-problems, and we will see what this means shortly. A common misinterpretation is that if we have a recurrence-based algorithm, then we have dynamic programming. For example, consider the following recurrence, which you might remember from the first section, where we discussed the maximum sum subarray problem. This recurrence has no overlapping subproblems. That is because if we implement this recursively and call f of n, this will not compute subproblems multiple times. It will be an efficient solution. It will still be order n to compute or f of n. It will be just as efficient as using a for loop to compute f of n. That means that in order to solve for f of n, if we use a direct recursive implementation of this recurrence, subproblems will not be computed multiple times. Therefore, we do not have overlapping subproblems, and it is a stretch to consider this as dynamic programming. However, some authors do consider it dynamic programming because of the fact that we have a recurrence-based solution and that we have optimal substructure. I don't want to say that those authors are necessarily wrong, because after all, this is just a matter of classification and it does not do anything to help understanding or proper implementations. However, for this material, we will consider this as a misinterpretation and a misclassification as dynamic programming, and we will avoid such misclassifications in similar cases. Common dynamic programming recurrences are the Fibonacci sequence, for example, or the Fibonacci recurrence. This will generate overlapping subproblems because if we implement this recursively, then when we call f of n minus 1 here, this will again call f of n minus 2, which is also called here for f of n. So f of n minus 2 will be computed twice, once when it is called by f of n, and once more when it is called for f of n minus 1. Another one is this, which is the formula for combinations. So keep this in mind when watching the next videos.